Okay, so I'm trying again. Um, there was a complaint that there was something that was plagiarized, either audio or visual. So the original stream was stopped. So I'm back live again. If you had difficulty with the rough draft, or if you had difficulty with the final draft, I want you to go back and look at the rough draft and check the comments that I had made and also the um, response that I posted to get an idea of where I want you to go for the final draft. So go ahead and get that done this weekend if you can. Not this weekend. I'll start grading the final drafts today. And then if I send it back to you, try to get that to me by the end of spring break, okay? Um, what happened is that someone made a complaint that something was plagiarized, either audio or video, so they stopped the stream. I apologize. I don't know who would have complained that my house that's on video is plagiarized. Um, why we've got a quiz? Because we're learning. We're learning online. So I need to have a check for understanding of where you're at, right? So, nevertheless, we're starting this week with food for thought. So that's posted. Let me go ahead and bring the schedule that I wrote up here. Well, evidently not. Okay, so food for thought, that's due today. And that's a continuation of the conversation that we were having last week about um, the fact that we eat a lot of meat, and it's not the cow itself that's a problem for the environment, but the fact that because we want to mass produce beef, we've cleared a lot of land so that these cows have pasture and they're fed corn. That corn is not what they're built to eat, so they have a lot of gas. That's methane. Methane is a terrible, terrible greenhouse gas. It does far more damage than carbon dioxide. We don't hear as much about it because it doesn't stay in the environment for as long. Um, so it's not a problem for as long a period of time as carbon dioxide. Carbon dioxide, once it's there, it's hard to get rid of that. But anyway, the food for thought is a continuation on that idea that what we eat matters, what we choose to eat matters. Then for tomorrow, you have calculate your carbon footprint, which is a fun activity. There's some questions in there for you to answer, and then you can submit that. And again, you can either type your responses or you can handwrite them and take a photo and go ahead and upload it. And then there's study guide. So we'll start going over the information that's in the study guide. So if you don't get this information written down that we go over today, you can always watch this again later once you pulled out that study guide, and you can start putting some answers in on that. And again, you can either type answers or you can handwrite them, take a picture, and submit that. And then on Thursday, we're having a quiz on climate change. So let me take a look at these questions again. I apologize if you got cut off, but someone had made a complaint that either the audio or video was copyrighted. So I had to close that stream. Well, they cut the stream off, and I had to start a new one. Um, let me see. Don't trip. Are you giving us work on spring break? So I posted a couple of things that if you want to do the extra credit assignment that's posted there, go ahead and do that extra credit assignment. If you have work to make up from quarter three, because with all of this that's happening, quarter three is going to be the larger portion of your grade, right? Um, so if you want to make up any of that work from the last week, the grading that I did that last week was greenhouse effect. Um, I can't remember the name of the climate change web quest. And then, of course, that last assignment sheet. Those were all graded that last week. So you might not have realized that you didn't get those turned in. So you can make that up. That's the only thing I'm asking you to do over spring break. When we come back from spring break, we will be covering electricity. Now, I do want to say again that um, as far as grading goes, it seems like the physics department has decided that we will not do a final exam, but we are doing a performance task for waves. After electricity, we'll be getting to waves. Um, Actually, I can't promise that that's the last performance task that we have, but the last performance task will count as your final exam. So it counts as 20% of your semester grade. Um, the quarter three makeup work, putting a stop on that on April 30th. If we had been in school, I would have given you like the first week that we were off due to climate, due to the COVID-19. I would have given you that week to make up any of that work to improve your grade. So extending it to April 30th, that's because of the situation that we're in. All right. So I'm trying to do everything I can to help you improve your grade. So don't forget to go back into Aries and look at your quarter three grade. If you didn't get a passing grade, and I have not found out, but in college, passing is C minus. Um, so I don't know what it will look like at the high school level, but if you don't have at least a C minus, you should do something about improving that third quarter grade. Because if you have less than a C minus for the entire semester, then you're not going to get credit for it. Um, but again, I can't say for sure that that's what the district is deciding. They have said either pass fail or credit no credit, and they haven't given us a base for what pass fail is. So that's yet to be determined. I don't want to get into heavy duty thinking about that. But do spend, if you don't like the grade that you got for third quarter, go ahead and make up some of that missing work. The assignments that I'm accepting are the ones, the climate change web quest, greenhouse effect, and then the assignment sheet from the last week. Of course, you can't make up any of that work from that last week if it's not signed off. But if you were not there to turn in that assignment sheet, you can drop that, and you can drop that in turnitin.com. Okay. Let me see. Other questions. Don't make me interested in doing stuff. Sorry. We're in this situation. Nobody asked for this situation. And I don't think anyone believes it's better than being in the classroom, but it's what we can do at this time, okay? And I want you to get your credit for your stuff. Hello, darkness, my old friend. I'm sorry. I'm sorry everything's so dark. Struggling with the other stuff, and you keep adding stuff. So then over the spring break, that's a good time to try to catch up. Goo goo. There is no late penalties, right? Not at this point. There are no late penalties. Starting after spring break, I'll have to be considering, as we move forward from spring break, if I'll be putting in late penalties. Okay, so let's start talking about the quiz that you're going to be having on Thursday. So actually, I don't think I have to write anything. I have to find my paper though oh, here we go. Nope, that's not it. So if you have a study guide in front of you, you can pull it out now. Maybe you want to split the screen so that if I put something up here, you can still see it. But mostly, I'm not going to be writing down the answers, because then what is it that you're going to do? You're going to take a picture of it and use it on the test. And of course, the study guide, you're going to be using that when you take the quiz, right? I'm not going to be there to take it away from you. So go ahead and do it. Just do it and make the quiz go quicker for you. It's 10 multiple choice questions. So explain Earth's energy balance. So Earth's energy balance is the incoming energy from the sun compared to the outgoing energy from Earth. And as you know, as we increase our greenhouse gases, more of the energy that we receive from the sun gets trapped in our atmosphere. So less and less is going back out into space. So that means that the planet is warming. So we need to try to be doing something about that. Okay, number 2, explain what happens to energy from the sun after entering Earth's atmosphere. So some of it gets absorbed by oceans, land, and atmosphere. Some gets reflected back into space. As the oceans are soaking up some of that heat, they're holding that heat, so that heat warms the planet even more. And because there's more heat and the oceans are warming, there's more evaporation, so clouds form. And we talked about clouds a couple of times. Sometimes they, depending on actually the type of cloud and where they're at in the atmosphere, dictates whether they're going to cool the earth, or because they're blocking sun from entering, or whether they're going to warm the earth because they're not blocking the sun that's entering, and they're not reflecting light back out. Not light, the sun's energy. They're not reflecting it back out to space. So let me see if I can do a little bit of a diagram on that. You have a link to look at the first video that we went over in the classroom on the energy balance. So the link is there. You can take a look at that. That gives you a pretty good idea. I don't know, this is going to be hard for me to do because I'll have to stand in front of the camera to do it. But the basic idea that we looked at in that video is that we have light coming from the sun, or energy coming from the sun, and that enters our atmosphere. Some of it continues into the atmosphere. Let's see, let's put the Earth down here. Some of it continues in and some of it reflects back out. Okay, so let's say this is our atmosphere. Oh dear, I didn't get that going far enough out. So this is our atmosphere here. This is the Earth here at the bottom. So some of this warms the Earth. And then we have some that the Earth is reflecting back out into the atmosphere. So the Earth has warmed. Some of that energy is being reflected back out into the atmosphere. And then some of that, the greenhouse gases, I'll just put, well, I have to put the whole thing now. But not just the greenhouse gases. The greenhouse gases make it possible for us to have an atmosphere. If we didn't have greenhouse gases, we wouldn't have an atmosphere. It would be like the moon. When the sun is shining on the moon, it's very hot. When the dark side of the moon is very cold, and we don't want that. We can't survive with that. And then these greenhouse gases reflect energy back, and that's re-radiated heat or re-radiated energy. That's heat, infrared. Okay, so some is going into the atmosphere and that's getting reflected back again. So this is a basic idea of what is happening. We've gone through some feedback loops before about global warming. We've done some with clouds. We've done some with albedo. But that's a basic idea. So that's number 2. What's happening to energy from the sun after entering Earth's atmosphere? Next, it's asking for an ice albedo feedback loop. So I've actually done one of those. Okay, that looks pretty good. Okay, so here we have the ice is melting down at the bottom. I'm hoping that you can read that. I can't hold the laptop there, and maybe I can get this a little bit higher. See if I can get it higher and closer. All right, so we have some of the stuff cut off. So we have the ice melts down here. The melting ice means that we have a lower albedo. That means that less energy is being reflected back out of the atmosphere into space. And so that means that the temperature warms. The warming temperature leads to more ice melting. It also leads to warming of the oceans. It warms the oceans and other water that we have. And when that happens, clouds form. We have evaporation and clouds form. Some of that energy is reflected into space. And again, we talked about that. Sometimes, depending on the type of cloud and where it is in the atmosphere, dictates whether it's going to reflect energy back into space or whether it's going to trap energy and lead to more warming. Then we have the greenhouse gases. As the greenhouse gases in the environment increase, we get temperature warming. So this is a basic ice albedo one. There are much more complicated ones that you can look at online, but the idea is that parts of it are negative, um, where the clouds form. Some energy is reflected, so that would be negative, and so that means that the climate cools, the temperature cools, but mostly because as the temperature warms, more ice melts. That's a positive feedback loop, and we don't want that. Sounds like we want it because we're saying positive. Usually positive is good. um, but what's happening is that change in the environment, the warming temperature, is out of control. So we want to do something about those greenhouse gases. Okay, number 4. I'll try to go to 8 today. There's 16 questions on the guide. How does the atmosphere of the Earth affect the amount of incoming, outgoing energy? So, again, talking about the atmosphere is like a blanket that's wrapping the Earth, keeping us nice and cozy and warm. We don't want to be like on the moon. We want to have an atmosphere. Without the atmosphere, there would be no life on Earth. Greenhouse gases are part of that cycle, and we need them so that we have an atmosphere. Greenhouse gases trap energy in the atmosphere. So, yes, we want some greenhouse gases. Too much in the line of greenhouse gases is going to trap too much energy in, and we have less energy leaving the earth than we do coming in. And that means the temperature rises. If we don't have enough, we get an ice age. So we have to have enough greenhouse gases for us to be comfortable living on the surface of Earth, but not too much. Um, the more greenhouse gases in the atmosphere, the more energy is trapped and the less that's reflected. The more greenhouse gases, the warmer it gets. So that's global warming. Okay, number 5. What are the 4 greenhouse gases that the FET sim covered? So one is water vapor. And I know water vapor, it's just water. But once that water vapor gets into the atmosphere, it's a really strong greenhouse gas. You know how, let's say you go to the beach, it's really hot outside. Why do you go in the water? Is water as hot as it is outside? Oh, it's a lot cooler, right? So that's because it takes longer for the water to absorb that energy. It takes longer for that water to heat up. So once it heats up, it holds on to that energy, and it takes a long time to cool down. So the same thing is happening when that water gets in the atmosphere. It takes a long time to heat it up, but once it heats up, it hangs on to that energy because of the heat capacity of water. So water vapor is really a very bad greenhouse gas, or a very strong greenhouse gas. Yes, we need some in the atmosphere, or it's never going to rain. We have to have rain, or we can't grow crops. Um, so we do have to have water vapor in the atmosphere, but it's a very strong greenhouse gas. Next is carbon dioxide. Everybody has heard about carbon dioxide. It's mostly what we're doing with the fossil fuels. We're burning fossil fuels and releasing carbon dioxide into the air. Um, Carbon dioxide stays there a long time. It's really hard to break that apart into other things. Whereas the methane that's from, I'm trying to think of the Mel Gibson movie that everyone's surviving on the pig poop. I can't think of the name of it, but it's methane. They're using methane as their energy source. Um, Once methane gets into the atmosphere, it's a really destructive, really strong greenhouse gas, but it doesn't stay there that long. It cycles back into um, the environment quickly. So um, methane is bad, but nitrous oxide is another one that's bad, and that's also coming from different things that we use, like cleaners and um, I can't. Oh, fertilizers. That's a big one that releases the nitrous oxide also. Um, So again, with farming, that's one of the balances that we need to try to come to with farming. Farming has become an industrial um, way of growing our food, and it wasn't like that a long time ago. Um, so not only does the farming, because they're using fertilizers and pesticides and things like that, um, but also because they're using tractors, and tractors are releasing greenhouse gases. So there we have to consider things to do about what we eat. That's the assignment for today. Think about what it is that you eat. What are the choices that you make when you eat? Okay, number 6. Which is most detrimental to the atmosphere in the short run? So we already said that. That's methane. And which remains in the atmosphere the longest, thereby driving climate change. And that's the carbon dioxide. So that's why everyone talks about carbon dioxide, but methane is not good either. So we'll do one more and then I'll take a look at questions. I don't see any questions. Can we use the notes on the quiz? Yes. I can't stop you, so yes. 8, what activities are sources of greenhouse gas emissions in the US? We have transportation, heating and cooling, electricity, industry, agriculture, and livestock, and also forestry. There, if you investigated forestry, you can see that there are some problems with the way that we manage our forests. What activities? Yeah, so transportation is a big one. Everyone knows that we're trying to go to electric cars, but don't forget, how do you make your electricity? PG&E uses something like 35% fossil fuels. Yes, they're going in the renewable direction, but they use fossil fuels to produce about 35% of their electricity in this area. Um, so electricity is only the right answer if we fix how we're producing our electricity. Um, Heating and cooling, so that's a big one. Everyone likes to keep it at 70 degrees in the winter when it's cold outside, and everybody likes to keep it at 70 degrees in the summer when it's really hot outside. And some people like to keep it colder than that. But let's say if you want to keep it at 70, um, there's a lot of energy that goes into doing that for your home. So, heating and cooling, electricity, also, um, that's where a lot of our greenhouse gas emissions come from. Industry, we kind of know that, right? And some industries are really good and conscientious about that, and others aren't. Agriculture and livestock, we talked about that at the beginning of the session today. And then forestry, we haven't really talked about that, um, but that's pretty far down on the list. So let me see. There is no late penalty. Right at this time, there is no late penalty. Uh, Message retracted. Are the power plants near the delta using fossil fuels? I really couldn't tell you. I don't know. There used to be a plant out there that was totally renewable. Everything about what was happening at that plant was renewable. So that means that any emissions that they had, they added other things to make them better for the environment. So I'm trying to think of the term for that, and I can't think of that. All I can think is doping, and that's different. But they also built their buildings so in such a way that they had filters it inside the building. So as air would pass through the building, they had carbon collection there. So they had filters collecting carbon directly from out of the air. They had like solar on top of their building so that they weren't creating um, any greenhouse gases by working by doing what they had to do every day. So everything at that place was totally renewable, but that's not there anymore. So I don't know if that has been replaced with something else um, or not. So I really can't answer what the power plants near the delta are doing. Are there any other questions from anybody? We talked a little bit about the final exam at the beginning. I can't really say too much more than that about grades at this point. Have to wait for direction from the state as well as the district on those decisions. District is in contact with the colleges to decide on whether it's going to be pass fail or credit no credit. And again, we haven't gotten any guidance on that yet. So take care. Get to those assignments this week. I didn't answer emails over the weekend, but I will get to them today. And take care. Stay healthy. Stay safe. I think the last day for school was June 3rd. But I can't say off the top of my head. When was school originally gonna end? And it's that first week of June. I know that. I don't know if it was Monday, Tuesday, Wednesday. Okay, take care. Stay healthy. Bye bye. Sorry that we had to close and then reopen.